this of the total amount of matter in the universe, or by seeing to the very edge of the cosmos. Radio telescopes are able to detect distant quasars billions of light years away, expanding with the fabric of space. By looking far out into space, we are also looking far back into time, back toward the horizon of the universe, back toward the epoch of the Big Bang. Radio telescopes have even detected the cosmic background radiation, the fires of the Big Bang, cooled and redshifted, faintly echoing down the corridors of time. This is the Very Large Array, a collection of 17 separate radio telescopes, all working collectively in a remote region of New Mexico. Modern radio telescopes are exquisitely sensitive. A distant quasar is so faint that its received radiation by some such telescope amounts to maybe a quadrillionth of a watt. In fact, this is a reasonably stunning piece of information. The total amount of energy ever received by all the radio telescopes on the planet Earth is less than the energy of a single snowflake striking the ground. In detecting the cosmic background radiation, in counting quasars, in searching for intelligent signals from space, radio astronomers are dealing with amounts of energy which are barely there at all. These radio telescopes, rising like giant flowers from the New Mexico desert, are monuments to human ingenuity. The faint radio waves are collected, focused, assembled, and amplified, and then converted into pictures of nebulae, galaxies, and quasars. If you had eyes that worked in radio light, they'd probably be bigger than wagon wheels, and this is the universe you'd see. An elliptical galaxy, for example, leaving behind it a long wake glowing in radio waves. Radio waves reveal a universe of quasars, interacting galaxies, titanic explosions. Every time we use another kind of light to view the cosmos, we open a new door of perception. As the murmurs from the edge of the cosmos slowly accumulate, our understanding grows. This is an exploration of the ancient and the invisible, a continuing human inquiry into the grand cosmological questions. Another important recent finding was made by X-ray observatories in Earth orbit. Artificial satellites launched to view the sky, not in ordinary visible light, not in radio waves, but in X-ray light. There seems to be an immense cloud of extremely hot hydrogen glowing in X-rays between some galaxies. Now, if this amount of intergalactic matter were typical of all clusters of galaxies, then there may be just enough matter to close the cosmos and to trap us forever in an oscillating universe. If the cosmos is closed, there's a strange, haunting, evocative possibility, one of the most exquisite conjectures in science or religion. It's entirely undemonstrated. It may never be proved, but it's stirring. Our entire universe, to the furthest galaxy, we are told, is no more than a closed electron in a far grander universe we can never see. And that universe is only an elementary particle in another still greater universe, and so on forever. Also, every electron in our universe, it is claimed, is an entire miniature cosmos containing galaxies and stars and life and electrons. Every one of those electrons contains a still smaller universe, an infinite regression, up and down. Every human generation has asked about the origin and fate of the cosmos. Ours is the first generation with a real chance of finding some of the answers. One way or another, we are poised at the edge of forever. Except for planetary exploration, the study of galaxies and cosmology, what this episode was about, have undergone the greatest advances since Cosmos was first broadcast. For one thing, at last we have a good photograph of our own Milky Way galaxy, about 100,000 light years across. Here it is. It was taken by NASA's COBE satellite. We see it edge on, of course, since we're embedded in the plane of the galaxy. But you don't need a spacecraft to see it. If it's a clear night tonight, why not go out and take a look at the Milky Way? There's also new evidence suggesting that the Milky Way is not so much an ordinary spiral galaxy as a barred spiral, like this. Important work has now been done on mapping how the galaxies are scattered through intergalactic space. To the surprise of a lot of scientists, on a scale of hundreds of millions of light years, the galaxies turn out not to be strewn at random or concentrated in clusters of galaxies, but instead strung out along odd, irregular surfaces, like this. Every dot in this computer animation is a galaxy. The computer lets us look at this distribution of galaxies from many points of view, but this is how it looks from the Earth. There's an odd mannequin shape that is presented by the distribution of galaxies. This work has been done mainly by Margaret Geller with her collaborator John Huckra at Harvard University and the Smithsonian Institution. It's a little like soap bubbles in a bathtub or in dishwashing detergent. The galaxies are on the surfaces of the bubbles. The insides of the bubbles seem to have almost no galaxies in them at all. An average bubble is about 100 million light years across. And that means that we've mapped still only a very small volume of the accessible universe, the galaxies nearest to us. But pretty soon, we should be able to extend this search out to enormous distances, out to distances so far away in space that we're looking back to the time that galaxies and their structures were first forming. And this poses a real problem. Most cosmologists hold that the galaxies arise from a pre-existing lumpiness in the early universe, with little lumps growing into galaxies. But the background radiation from the Big Bang that fills all of space has now been carefully measured by that same COBE satellite that took that picture. Now, those radio waves seem almost perfectly uniform across the sky, as if the Big Bang weren't lumpy or granular at all. But if the early radiation and matter in the universe weren't lumpy, how could individual galaxies form? How could the bubbles form? Is there a contradiction between the uniformity of the Big Bang radio waves and the bubble structures formed by the galaxies? That's the question. When our survey of the galaxies reaches out to billions of light years, we'll have the answer to this question.
Incidentally, maybe you're thinking that the bubbles imply a bubble maker. But then I'd have to ask you, who made the bubble maker? There's another infinite regress lurking here. And to one of the grandest questions, whether there's enough matter in the universe to close it, the only fair answer is that we still don't know. If it is closed, what is the hidden matter that's closing it? Is it faint stars, black holes, massive neutrinos, some exotic kind of dark matter unknown on Earth? We don't know. But there are reasons to think that we'll soon find out the answers.